Hello everyone, welcome back to DSA plus AI agent series. In today's video, we are going to solve an easy but important array problem called check equal arrays. This problem will help us understand how to compare two arrays when the order of elements does not matter, but the frequency of every element does matter. Let's understand the problem clearly. We are given two arrays A and B of equal size. We need to determine whether both arrays contain exactly the same elements. The arrangement of the elements may be differ. However, if an element appears multiple times in one array, it must appear the same number of times in the other array as well. For example, the let's see this array 1 2 5 4 0 and the second array 2 4 5 0 1. We can see that the order is different, but both arrays contain the values 0 1 2 4 and 5. Therefore these two arrays are equal and the answer is true. Now consider another example. The first array is 1 2 5 and the second array is 2 4 15. These arrays do not contain the same elements, as we can see. Only the value 2 is common, as we can see, but 1 and 5 and here is 2 and 15. Therefore the answer is false. Now let's focus on one very important statement from the problem. The problem says that if there are repeated elements, their counts must also be equal. For example, these both arrays contain one occurrence of 1, right? We can see here two occurrences of 2 and one occurrence of 5. Therefore, they are equal. But suppose the arrays are this. Both arrays contain the values 1, 2 and 5, but their frequencies are different. In the first array, 2 appears twice. In the second array, 5 appears twice. Therefore, these arrays are not equal. This also tells us why we cannot simply convert both arrays into sets. Because a set only tells us whether an element is present. It does not preserve how many times that element appears. For example, for example, both 1 2 2 and 1 1 2 will become this set, right? But the original arrays are not equal because their frequencies are different. So using only a set would give an incorrect answer. Now let's discuss the possible approaches. The first approach, what we can think of sorting. We can sort both arrays and then compare them element by element. For example, 1 2 5 4 0, this example. After sorting, it will become 0 1 2 4 5, and the second array 2 4 5 0 1, it will become 0 1 2 4 5. This will be, and those two sorted will be equal. Then we can return true, right? So the approach is simple, but sorting takes big O of n log n time. We can solve the problem more efficiently in big O of n time by using a hash map. The idea is straightforward. First, we count the frequency of every element in the first array. Then we traverse the second array and decrease the corresponding frequencies. If we find an element in the second array that does not exist in the frequency map, the arrays are not equal. Similarly, if an element occurs more times in the second array than in the first array, its frequencies will become invalid, so we will return false. Let's understand this with a dry run. Now I have taken this as a dictionary. Now we can see that first element is 1. So I will write 1 is to 1. This is our element and this is the frequency. Now the second element is 2. So the frequency is still 1 because I have only 1, 2 here. Now the next value is 5. So I will write like this. 5 is 1. Now the next element is 4. So I will write like this. 4 is to 1 because I have a 1 4 here. Now the next element is 0. I will write 0 is 1. Now at this point every element from the first array has a frequency of 1, right? Now we traverse the second array. The first value is 2. 2 exists in the map or dictionary, so we decrease its frequency from 1 to 0. We will subtract the values. 1, now I am doing it 0. Since the frequency becomes 0, we can remove it from the map, right? The next value is 4. 4 also exists, so we will do it 0. 1 minus 1 0 and the 0 frequency, that's why I am removing it. The next value is 5, so this will also become 0 because there is only 1 5 and 1 minus 1 is 0, and since it is a 0 frequency I will remove it. Next value is 0. 0 will also be removed similarly, and similarly the all the set will be empty after traversing whole second array. At the end the frequency map is empty. This means every element and every occurrence from the first array was matched by the second array. Therefore the arrays are equal and we return true. So this concept we will be using further. Now let's dry run a case where the answer is false. We are taking another arrays. So these are our two arrays. Again, I am starting from a dictionary or map. We will traverse the first array. First value is 1, so I will write 1 is 1, and the second value is 2, that's why I will write 2 is 1, and the third value is 5, that's why I will write 5 is to 1. Now we will process the second array. The first value is 2. 2 exists, so we decrease its frequency to 0 and remove it. The next value is 4. 4 does not exist in the frequency map. This means 4 was not present in the first array. Therefore, we immediately return false. Okay. So this will be our basic idea. Now let's write the code. First, although the problem says that the arrays are of equal size, but it is still good programming that we check their lengths ourselves. So if length of array A is not equal to length of b, then return false. Now I will be defining a frequency dictionary. This dictionary will store each value as a key and its count as a value. Now we will traverse the first array. For every value of a, we write frequency of value. This get method checks whether the value already exists in the dictionary. If it exists, we get its current count, and if it does not exist, the default count will be 0. Then we add 1. After this loop, the dictionary contains the frequency of every element in the first array. Now we will traverse the second array. For every value in B, we will first check if value is not in frequency. Then we will return false. And this means the second array contains an element that is unavailable in the first array. Otherwise, we will decrease its frequency by 1. After reducing the count, if the frequency becomes 0, we delete the key from the dictionary. Now, after deleting 0 frequency values, it will keep the dictionary small and also make our final check simple. After processing the complete second array, we will return whether the frequency dictionary is empty. If the dictionary is empty, all occurrences matched correctly. Otherwise, some elements from the first array were not matched. Now, let's run the code for once. Now, let's understand why this code correctly handles duplicate values. Suppose this array 1 2 to 5 and 2 5 1 2. After processing the first array, the frequency map will be like this. So after traversing the first array, the frequency of 1 is 1, like we can see here, and the frequency of 2 is 2, like we can see here, and the frequency of 5 is 1. Now we will traverse the second array. The first value is 2, so we will decrease the frequency by 1. 2 minus 1 is 1. The next value is 5. So we will decrease the value 1 to 0, and we will remove the value because the frequency reaches 0. And the next value is 1. So we will remove the value because 1 will become 0. Frequency will become 0 and we are removing it. Now the last value is 2. So the frequency of 2 will become 0 and we will remove it. At last, the frequency map becomes empty. We will return true. Now let's consider this example, this array 1 2 to 5 and 1 2 5 5. The frequency map will look like this. First value is 1, so 1 frequency will be there. and second value is 2, so the frequency will be 1. Third value is 2, that's why we'll increase the value of frequency to 2, and the third value is 5, so we'll write like this. Now we'll traverse the second array. The value first value is 1, so we will decrease the frequency to 0 and we will remove it completely. The second value is 2, so we will decrease the frequency to 1. Third value is 5, so we'll decrease the frequency to 0 and we will completely remove that. Now the fourth value is the fourth element is 5, but 5 is no longer present in the map. This tells us that 5 appears more times in the second array than it's than in the first array. Therefore, we will return false. Now let's analyze the time complexity and space complexity. We traverse the first array once to build the frequency map, so that will take big O of n time. Then we will traverse the second array once to match the frequencies, that also takes big O of n time. Therefore, the total time complexity will be big O of n. In worst case, all elements may be different, so the dictionary may contain up to n elements. Therefore, the space complexity will can be big O of n. Now, let's briefly compare this approach with the sorting approach. With sorting approach, we'll sort the both arrays and compare them. So this will be the code for sorting approach. The solution is shorter, but the time complexity is big O of n log n because of sorting. The hash map solution takes big O of n time, which is better for large inputs. Since the constraints allow us array sizes up to 10 million, avoiding unnecessary sorting can make a significant difference. Before we finish, let's discuss a few common mistakes that we make. The first common mistake is using a set. As we discussed at first, that a set ignores duplicate counts, so it cannot correctly solve the problem. The second mistake is checking whether every element of one array exists in the other array. This will also ignore the frequency. For example, one array may contain a value twice while the other contains it only once. So this will ignore the frequency. The third mistake is forgetting to decrease the frequency while processing the second array. Building a frequency map alone is not enough. We must match and reduce the counts. The fourth mistake uh, is returning true without confirming all frequencies have been matched. Our final empty map check ensures that no unmatched elements remain. Let's quickly recap what we learned. Two arrays are equal in this problem when they contain the same elements with the same frequencies. Their order does not matter. A set is not enough because it ignores repeated counts. Sorting gives us an big of n log n solution, so we'll use hash map and it will give us an efficient big of n solution. We will count the elements of the first array and reduce those counts while processing the second array. If every count is matched, we will return true. Otherwise, we will return false. That is all of this problem. Now try writing the solution yourself before submitting it. Also test it with arrays containing duplicate values because that is where most incorrect approaches fail. If this explanation helped you, like this video, subscribe to coinslive and share it with someone who is learning data structures and algorithm. I will see you in the next problem. Thank you.